Okay, so Maddie, this is for you too. This is 3.1 class examples 6 to 10, page 167. Now, the first thing I'd like to do is just to review this theory because this is a different day. And the theory that we had so far, really important, was that we are studying geometric sequences. And geometric sequences, the definition of a geometric sequence is a sequence that has a common ratio between terms. This is very important. So you have a common ratio between terms. An arithmetic sequence, by contrast, would have a common difference between terms. We also discussed the fact that there were other kinds of sequences. So there are geometric sequences, arithmetic sequences, but we discussed that there were other sequences such as prime number sequences, Fibonacci sequences. But we're focusing on geometric. All right, common ratio between terms. That's the definition. Now, if you want to have a formula, we derived it last day, and the formula for the geometric sequence is AR to the n minus 1. This is the formula. Formula is only good if you know what it stands for. So this is for finding the general term or any particular term. You can find the 7th term, the 100th term, if you know A, R, and N. Now, A always stands for the first term. So that's always the first term. No, wrong one. A is always the first term. Get it right. Okay, there's your A, first term. R is your common ratio. Now, what's N? If you had to say it in words, what would N be? N is the particular position of the term you're trying to find. And then this is the expression for the general term. Or sometimes in some questions you could think of it as the last term. The term that you are trying to find, right? Different names. The common ratio we give the symbol R stands for. And a formula for the common ratio that we talked about last day was if you want to find the common ratio, take any term and divide by the preceding term. So that's a little formula for the common ratio. The other thing that we developed last day was a little schematic or a little visual for you visual learners, which is most of us, benefit from a little picture. Let's say if this is the first term and this is the second term and this is the third term and this is the general term or the nth term. The first term is A, and to get the second term you take A and multiply by the common ratio. To get the third term you take A and then multiply by the you take A R and then multiply by the common ratio, which is another factor of R. So you end up with R squared. And then we notice the pattern that R is always the exponent for R is always one less than the term you're finding. And that allowed us to develop the formula AR to the 1 less than n minus 1. And this became our formula. So this is a nice picture to have in your mind when you're solving problems involving geometric sequences. Okay, so with that, I think that's kind of a summary of where we were last day, and we can look at these problems. Let's look at problem number 6. What is the general term for the sequence? Well, if I'm finding the general term, I know what I'm looking for. I'm looking for AR to n minus 1. In order to find this, I need A and I need R. So do I know A? Yes. A is 1/4. Do I know R? I can find R by taking term 2 and dividing by term 1. So I get 1/8 divided by 1/4, which is 1/2. All right, so now if I want to find my general term, I go over here. A is 1/4 and R is 1/2, and it's all to the n minus 1. If you were doing this on a multiple choice format, you probably wouldn't find your answer among the 4 to choose from. They would probably be in base 2. So let's rewrite this in base 2. And what do you get? 4 is 2 squared, so 1/4 is 2 to the negative 2. This is 2 to the negative 1, all to the n minus 1. Power of a power, multiply the exponents. When the bases are the same and you're multiplying, you leave the base end, add the exponents. So you end up with 2 to the negative 1 minus n. Okay, class example 7. In class example 7, we're given a sequence. 32, 64, 128, and 16,384 is our the final term. The first thing you would want to do is that you cannot use any of the theory unless you are sure that you have a geometric sequence. So you better decide what kind of a sequence you have. It looks like we're multiplying by 2. So yes, this is geometric. Once you know it's geometric, you can use the geometric sequence formulas. Part A says, find the number of terms in the sequence. How many terms are there in the sequence? That's the question. So what do I know? Well, I know the first term. And I know R. And I know one other thing. What do I know? I know the last term, or the general term. The last term is 16,384. And this is where the schematic might be good for some of you, because this is term 1, this is term 2, this is term 3, and this is the, well, we're not sure yet, are we? The nth term. Okay, now we're going to write down our formula. The nth term formula is AR that we derived last day to the n minus 1. That's a formula. Memorize it. And we're going to substitute into this formula. The last term is 16,384. The first term is 32. R is 2. And we're to the power of n minus 1. Okay, great. Now we want to solve for n because n is the number of terms that we're looking for in the sequence, n. So we classify this equation. We ask ourselves, what kind of equation do we have? When we see a variable in the exponent, we know we have an exponential equation. So then we say to ourselves, how do you solve an exponential equation? Either get the bases the same or take the log of both sides. So I'm going to divide both sides by 32. And I recognize that 512 can be written in base 2. If you don't recognize that, you would have to take the log of both sides. But I recognize that it's 2 to the something. 2 to the 9th. And now you see that when the bases are the same, you can leave the base. No, when the bases are the same, you can do what? You can equate the exponents. Okay, so then we just solve for n, and we get n is 10. That tells us that there are 10 terms in the sequence. Okay, the next question says, which term in the sequence is 1024? So let's see. Let me look at my sequence. Here's my sequence. And now what we're wondering is, one of the terms in here is 1024. And which term is this? That's the question. So if I forget about this, I could put, which term is this one, right? Okay, so in order to do this one, let's write down what we know. It's always good to write down what you know. Do we know A? The first term is 32. The ratio is 2. It's asking which term is in the sequence is 1024. We don't know which term it is, but we do know that the term that we're looking for is 1024. Now we'll use our formula that we derived. The nth term in a geometric sequence is AR to the n minus 1. And we'll fill in all our information. So the nth term is 1024, 1024. A is 32, R is 2, and it's the n power of n minus 1. Again, isolate the power, divide both sides by 32. And recognize that you have an exponential equation, so go to base 2. And when the bases are the same, you can equate the exponents. So 5 is equal to n minus 1, and the n is 6. That means that 1024 is the 6th term of the sequence. Okay, class example 8. This is a difficult question when you first come across it. Let's read it. Given a geometric sequence with the 4th term is negative 54 and the 7th term is 1458. You are supposed to find the first term, the common ratio, and the general term. Well, let's just focus on what we know here. We know this and we know this. I think for this question, I would draw a little picture. You can just watch. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Term 4 is negative 54. Term 7 is 1458. That's good, right? That's what we know. But we also bring something else to the table, is we know the formula for the geometric sequence. This is A times R, this is A times R squared, so what's this one? A times R cubed. And what's this one? A times r to the 6th. So what am I doing at this point? At this point, I'm writing down what I know about this problem. I know that is good information and this. So I think I have everything I know about this problem written down. That's a strategy, all right? For a difficult problem, put down what you know. Now focus on what you're trying to find. You're trying to find, let's see, the first term. How am I going to find A when this is my given? You've got to go from what you know to what you don't know, right? So in what I know here, there's two variables. There's an A and an R. Let's see. Maybe I should write it like this. I know that AR cubed is negative 54. And I know that AR to the 6th is 1,458. I have two equations with two variables. So you have to use a different strategy to solve them, right? Now, this is a very common strategy I'm going to show you in this chapter. If I take the ratio of this term to this term, I'm going to find the common ratio, R. But what I'm going to do is a little bit different. You probably haven't done this before. I'm going to say AR to the 6th is to AR cubed. This is a strategy. The reason I'm doing that is that when I do this, A over A is 1, and I get R to the 6th over R cubed, which is just R cubed. And I'm trying to find R, right? So that's why I'm doing this. I'm saying this is to this as what? AR to the 6th is 1,458 is to negative 54. Now, A over A is 1, and R to the 6th over R cubed is R cubed. And when you divide 1,458 by negative 54, you get negative 27. And take the cube root of, and you get R equals negative 3. Now, one might ask, how would you think of that? Well, once you've seen it, you will think of it. It's a strategy, right? You just add it to your other strategies that you have for solving. All right, so once we have R, we're pretty good, because then we can take this R and we can substitute it into there and solve for A. So A times negative 3 cubed equals negative 54. That's negative 27A equals negative 54. So A is equal to 54 divided by negative 27. A is equal to, so did I make a mistake here? Oh, this is negative. A is equal to 2. What else was I supposed to find here? I was supposed to find the first term. I found it. I'm supposed to find the common ratio. I have it. And the third thing I'm supposed to find is the general term. The general term is AR to the n minus 1. So that is 2 times wow. 2 times negative 3 to the n minus 1. That's your answer. All right, next problem. Class example number 9. So read the problem. x plus 5, and x plus 9 are the first three terms in a geometric sequence. I'm going to draw a picture of this. X plus 5, and x plus 9 are the first three terms in a geometric sequence. Determine the exact value of each term. In order to determine the exact value, I need to find x. How will I do this? I'm going back to the problem. I must have some more information that I don't have down here. X plus 5, x plus 9 are the first three terms. Got that. In a geometric sequence. What's the definition of a geometric sequence? Common ratio between terms. What's that mean? That means that term 2 is to term 1 as term 3 is to term 2. Now, do you know what to do? Take the ratio of term 2 to term 1 and equate it to term 3 to term 2. Now we're back in grade 10. So let's stop, just pause for a sec, and look at, because we can solve this. This is not going to be a problem to us. It's the problem here is to get this. And to do that, you had to remember that the definition is a common ratio between terms. That's the key to solving this problem. The rest is trivial. Okay, so solve it. If this is not trivial, well, next week we're going to do some practice at this. Fraction work. This is, so you multiply it out and you subtract x squared from both sides. And you subtract x from both sides, 9x from both sides. And you end up with x equals negative 25. But you're not trying to find x. Well, you are. Actually, we are. You're supposed to find the first three terms of the sequence. So go back to your picture. X is negative 25. That's good. The next one is negative 25 plus 5, which is negative 20. And the third one is negative 25 plus 9, which is negative 16. So the answer to this question would be that the first three terms in the sequence are negative 25, negative 20, and negative 16. Geometric means. Geometric means are terms between given terms. So in this question it says insert 4 terms, fancy, 4 geometric means, between 81 and 1 over 729. So this is what it means to insert 4 geometric means. Again, I'm going to go back to that visual. This is AR, AR squared, AR cubed, AR to the 4th, AR to the 5th. There's some good information, and here's some more. So what do I know? I know that A is 81. And I know that AR to the 5th is 1 over 729. And I'm trying to solve for R. So what do I do? substitute the 81 in for A. And solve this equation. Divide both sides by 81. Uh, 81 is 9 squared. I don't have a calculator up here, and I think 729 is 80 is a factor of 9, a power of 9. It's 9 cubed. Keeps it easier for me when I don't have a calculator. So if I'm finding the fifth root, if r to the fifth is 1 over 9 to the fifth, what's r? One over 9. If you don't like doing this, you can put it in your calculator and take the fifth root. Same thing. All right, so I have r. If r is 9, I can go back to my schematic. R is 1/9, excuse me. And I can take 1/9 of 81, and what will I get? Divide by 9, divide by 9, divide by 9. Multiplying by 1/9 is the same as dividing by 9. Divide by 9. And those are the 4 geometric means that we were asked to find right here. Okay, so in summary, geometric sequence, formula, AR to the n minus 1, memorize, know what the variables stand for, and that nice little picture that we've been drawing, right? And that visual. That's it. You guys can do the rest of these questions. Questions 1 to 15.